Hi, dear students. Today, the topic under discussion is motion and sound waves. So, let's discuss motion and sound waves. I have created 42 slides in order to convey the information and knowledge about the topic under discussion with reference to physics. First of all, you all students must be well familiar with the definition of physics. Physics is a branch of science which deals with the study of energy, matter, and relationship between them. Now, let's move to the slide and let's start the topic under discussion, motion and sound waves. To discuss motion, we are going to detailed discussion of the topic. The concept of motion in physics is one of the important topics in classical mechanics. Did you know that everything in the universe is always moving, even if you are completely still? You still belong to the earth. My dear students, as you know, there is a particular rule that every particle of the earth attracts the other particle. And with reference to the rule of gravitation and with reference to the rules of physics, we are also the part of universe. Although in smaller size, our planet Earth is a part of the universe as well as it is the part of the solar system. Our Earth, the third planet of the solar system, rotates on its own axis as well as it revolves around the sun. So, to understand that every particle of the universe is in a consistent motion, we can say that we are under motion. We are also in a state of motion, although we don't feel due to the environmental adaptations, but still we are moving. When Earth revolves around the sun, it results in the creation of the seasons. And while Earth rotates on its own axis with a particular speed, it results in the formation of days and nights. And this is the continuous process around the sun. In physics, motion is the change in position of an object with respect to the surrounding. Here, I would try to define the definitions of motion and rest with reference to the physics. If you are changing your position with reference to the observer, it means you are in a constant motion. But if you are not changing your position and location with reference to the observer, it means you are in rest. Observers are your surroundings. If you are driving a car, if and you observe your environment, so with reference to your environment, I mean to say with reference to your observer, you are going to change your position. The motion of an object with some mass can be described in the terms of the following: distance, displacement, speed, velocity, time, and acceleration. These are some important things in physics which state the motion very clearly. So let us discuss these things. Firstly, we have to go through all the details about the distance. Distance is the total path between the 2 points. It's basically a scalar quantity. In physics, there are two types of quantities: scalar quantities and vector quantities. Vector quantities are those quantities which require magnitude as well as direction for their complete description. And scalar quantities are those quantities which require only magnitude for their complete description. So, distance is a scalar quantity because it just has magnitude and unit. Its unit is meter. Distance is measured in meters. This is the unit of distance. Now, we are going to discuss displacement. As you know, the distance was the total paths between 2 points. Suppose there was A point and B point, and you had to travel from A to B with no particular direction. This was distance. Whereas the displacement is the minimum distance, the shortest distance from A point to B point, or you can understand that this is the minimum or the shortest distance from initial position to final position in a particular direction. Next, the displacement is a vector quantity. As I have already explained, that vector quantities are those quantities which require magnitude and direction for their complete description. Dear students, we count it as vector because we cover the distance from one point to another point in a particular direction. So here there is also direction along with magnitude. So this can be termed as a vector quantity. Displacement is represented in three types. There are basically three types of showing and representing displacement. If you write small d but with bold letter, this is a first type of representation of displacement. And second, if you write small d with arrow on it. And the third way to write and represent the displacement is if you write small d under an arrow. These are the three types to represent the displacement. An arrow shows that this is a vector quantity. Next one is speed. The distance covered in a unit time is a speed of the body. When a body covers 50 meters in 5 seconds, it can be said that the speed of the body is 10 meters per second. It is represented by V. Speed is represented by V, and the formula is V is equal to distance covered over time. Next, we discuss what is velocity. The term velocity is defined as the covered displacement or the covered displacement in a specific or in a particular direction in a unit time is called velocity. The formula of velocity is v over an arrow on it, and it is equal to d displacement by time. V is also a vector quantity. Velocity is a vector quantity. So to represent velocity, you put an arrow upon V, which shows that it's a vector quantity. Its unit is meters per second, and it is a measurable quantity. For example, when a body covered the distance of 100 meters in particular direction in a unit time or 10 second, then the velocity of a body will 10 meters per second if the body covers the distance within 10 seconds. Next one is time. Time is a measurable quantity which is consumed by a body to cover the displacement or distance. It is represented by small t, which shows that if we put small t, it shows that we have taken time as small t mathematically. Its unit is second. It's a physical quantity. There are 7 basic physical quantities, and now let's discuss acceleration. Acceleration can be defined as rate change of velocity of a body is called acceleration. It is basically a vector quantity, and it is represented by a, and I have told that acceleration is a vector quantity, so you have to put an arrow upon a to show that acceleration is a vector quantity. The formula of acceleration is change in velocity over time. The unit of acceleration is meter per second plus second. It equals to ms, meters per second square. Next, acceleration is always directly proportional to the acting force. So we can say that if acceleration is increasing, it directly means that force is also increasing. This is basically the detail of directly proportional. There is also a term in physics as well as in maths that there is also a relation of inversely proportional when if a quantity is increasing, the second quantity is decreasing. Suppose is if acceleration is increasing and the force is decreasing, this relation can be termed as inversely proportional. But acceleration is always directly proportional to the acting force. It means acceleration is increasing and in the same way force is also increasing, and force decreases, acceleration also decreases. So this relation can be termed as directly proportional. Acceleration can be positive, it can also be negative. When acceleration will be positive, let's discuss it. Acceleration will be positive if velocity of a body is increasing, and acceleration will be negative if velocity of body is decreasing. And when the velocity of a body is decreasing, the acceleration is negative, and this can be termed as retardation. I mean, negative acceleration can be said as retardation. It can be termed as retardation. When, for example, when a ball is thrown in the upward direction, then the velocity of ball is decreasing because there will be a specific height through point A from where the ball was thrown upward to the point where the ball lost its velocity. So it is basically and continuously decreasing through, it is covering the distance and taking the time. So when a ball is thrown upward in the direction, then the velocity of the ball is decreasing due to gravity action, because earth attracts everything till a specific height. Earth attracts everything towards its center, and this is called gravity. The gravitational force can be termed as the attraction of earth for all things is called gravity, and this is called gravitational acceleration, and it is called gravitational acceleration. It can be said that acceleration is negative if the ball is thrown upward the direction, and acceleration can also be termed as positive acceleration when a ball is free falling. Suppose you have thrown ball upward direction, and there will be a time when it will lose all its velocity and it will cover no more distance. So it will definitely fall, and this falling of the ball will be termed as free falling under the action of gravity. Then the acceleration will be positive. Next, let's discuss I have explained all these things: speed, velocity, time. Time is a measurable quantity which is consumed by a body to cover the distance or displacement. It is represented by t. I have also discussed acceleration in detail, rate change. So, acceleration is discussed in detail. Next, move towards the next slide. Let us discuss what is motion. Motion is the action of changing location or position. The study of motion without regard to forces or energy is called kinematics. Kinematics is a branch of physics in which we deal with the study of motion regardless of forces acting upon it and energies acting upon it. In broader sense, if you have a ball on the surface of the table, or let's discuss the example of billiard, and you apply a force, it will move. But if you are not applying any motion, any force, or any energy, but still the particles are moving, it is these things are discussed in kinematics, which is a branch of physics, and it is also the branch of mechanics. The general study of the relationship between motion, forces, and energy is called mechanics. Mechanics is the branch of physics, and it deals with the general study of the relationship between motion, forces, and energy. These all things affect each other. If you apply a force on a body for the very short interval of time, this is called impulse. It can be exemplified through bat and ball. When the batsman hits the ball, so there is a force acting on the ball, but this force is for very short interval of time. How this force applied on the body ball, and where the ball was thrown, how energy was consumed in hitting the ball, and how much energy was given to the bat. These all things are discussed in mechanics. It's a large field, and its study is essential to the understanding of physics. If you want to understand physics, you must be well familiar with the mechanics. That's why we discuss mechanics with reference to the physics. Next slide. The branch of mechanics that deals with both motion and forces together is called dynamics. In the branch of mechanics, we also deal both things, motion and forces. This is called dynamics, and the study of forces in the absence of changes in motion or energy is called statics. It means that if we apply a force to any body and it does not move, it can be termed as statics. Statics means the thing which is not moving. The still things are called statics, although they are under the action of forces and motion and energies. Types of motion in physics. The motion of an object depends on the type of force acting on the body. Examples of different kinds of motion are given below. Translational. This can also be said as translatory motion. It's the type where an object moves along a path in any of the three dimensions. Rotational. It can be understood as rotatory motion. It is a type where an object moves along a circular path about a fixed axis. It can easily be exemplified that the fan spins on its own axis, and the movement and the motion of the fan can be termed as rotatory motion. Another example in my mind to explain the rotational movement or the rotatory motion is our Earth, the third planet of the solar system, also rotates on its own axis with a particular speed, and in it results in forming days and nights. Next, linear motion. It is a type of translational motion where the body moves in a single direction along a single dimension. It can be exemplified through this example, which is very clear. If you hold some sand pebbles, some stone pebbles in your hand, and some beads in your hand, and if you are holding balls in your hand and you drop them free falling, their motion will be termed as linear motion, because it will be in a single direction along a single dimension. The balls will be free falling, and this type of motion is called linear motion. Periodic motion. It's a type of motion that repeats itself after certain intervals of time. Periodically movement is actually gonna be repeated. This is the why that it is termed as periodic motion. Let's discuss the next, simple harmonic motion. It's the type of motion like that of simple pendulum, where a restoring force acts in the direction opposite to the direction of motion of the object. It's very clear. Simple harmonic motion can be exemplified through the motion of a swing when it moves to and fro. When it is doing this motion, it restores. Suppose swings moved in such a way under an action of force, here it restores its motion and gets back. So this back and forth motion can be termed as simple harmonic motion, but under the effect of restoring force. Restoring force is the force which a body restores and it gets back towards its position, initial position, from where it started its movement. This restoring force is proportional to the displacement of the object from the mean position. Mean position is the central position, and it is this force is proportional to the displacement. It means if it covers a specific displacement from mean position, it will get back to the same from mean position to the back. It will go back in the same way from mean position as it moved forward from mean position. It will all happen under the restoring force. Suppose from this point a motion started, and this is basically the mean position, and it goes forward and it comes back on the mean position. From here, from mean position, it will get back under the force of restoring force. So this is actually a continuous process until an external force is not applied. There is also a rule in physics that all things will be moving if external force is not applied. Suppose if you are in space, and where and there you are moving, you will go on moving because there is not an external force applied. And if you are in rest, you are in complete rest, and you will remain in rest until the external force is applied. Next is projectile motion. It's the type of motion which has a horizontal displacement as well as vertical displacement. Horizontal displacement is actually makes an angle of 90. This is termed as vertical displacement. Projectile motion can be exemplified through the motion of rocket, missile, or such things. Firstly, the rocket, when it is launched, it moves in upward direction, but upon a particular point or on a specific height, it changes its position by making an angle of 45, and it moves in such a way. This motion can be termed as projectile motion, and this motion helps the rocket or missile to move at distance maximum travel towards the target. Now let us discuss oscillatory motion. It is the type of motion which is repetitive in nature within a time frame. Oscillatory motion can also be understood as vibratory motion because the particles are moving on a mean position. They are vibrating. They show that there is some type of oscillations. Oscillations can also be termed as vibrations. So due to vibrations, the sound is produced. Only this thing results in the production of sound. If you come to the bank of a pond and there you throw a pebble in the water of pond, which is still, which is not moving, you will observe that there is a chain of the waves. Why it happens? It happens because the particles of the water start oscillations, start vibrations, and these vibrating particles transfer their energies to the next particles, and this chain is a continuous. So in this way the waves are becoming. under the oscillatory motion. If it's mechanical, it is called as vibration. Let us discuss the next slide. Laws of motion. Laws of motions brought a revolutionized change and revolutionary change in the field of physics. Laws of motion were presented by Sir Isaac Newton. We will discuss here three laws of motion. Newton's laws of motion laid the foundation for classical mechanics today. Although the subject to limitations, to minor limitations, these laws of motions are valid anywhere and therefore used. These rules are called universal rules because these can be experienced, implemented, and understood easily everywhere and anywhere. Not only under the particular circumstances. Let us discuss the first law of motion. This is easy to understand. Any object will remain in its existing state of motion or rest unless a net external force acts on it. It means if a body is in rest, it will remain in rest until external force acts on it. And if it's in a motion, if a body is in motion, it will be moving until an external force acts on it. So if we ignore the resistance of air, all objects will fall to the ground under the act of gravity in a same speed. Second law, if an object has a certain mass, the greater the mass of the object, the greater will be the force required to accelerate the object. This can easily be understood if there is a body with greater mass, you will have to put more force in order to make it move. And if a body is of smaller size, you will need to put small force in order to make it move. Sir Isaac Newton gave his third law of motion in 17th century, 1686, which came as one of the most influential laws in the world. Let's discuss. The third law of motion states to every action there is an equal and opposite reaction. In simple words, every action has a reaction equal but opposite. There are many examples of the third law of motion, and universally hundreds of examples can be quoted and narrated as well. There is an easy example. If you are walking on the ground, you take your steps ahead and forward, back and forth. If you take a step forward, in the same during the while in the meanwhile your one step gets back, it moves towards the back side. So when your foot is back on the back, it pushes you in front or in forward position. There is a simple example. If you have a ball in your hand and you throw it towards the wall, it is your action, but it will return with the same speed after the collision with the wall. It will get back towards your side. By throwing the ball towards the wall, you put it under an action, but in the same way it returned back to you in return of reaction. So it means that if a body exerts a force F1 on body B, and the body B exerts a force F2 on the body A, then F1 is equal to F2. It is the case of a ball thrown by you on the surface of the wall, and it gets back in the same speed towards you under the reaction. That is the way, that is, they are equal in magnitude but opposite in direction. Whenever two bodies interact, they will exert equal and opposite forces. This law can be observed anywhere and everywhere in the surrounding. Next, some examples of action-reaction pairs are mentioned below. A swimmer pushes the water backward with his hands, and in return the water pushes the swimmer forward. This thus this process of action and reaction enables him to go forward during swimming. It can also be a backward movement. If you will put water forward, it will put you towards backward. Under the action, and they will be equal but in opposite direction. A man walking on the ground, while walking, a person pushes the ground in the backward direction, and the ground in return pushes the person in the forward direction, thus making them walk. I have exemplified that if you are walking on the ground, you walk through your feet and your feet exert a motion. They will push the ground back, and ground in return pushes you to the forward or to forward or in front position. This is basically the relation of action and reaction, and it is equal but opposite in direction. And here it can be implemented, it can be observed anywhere. So I was saying that Newton's laws are universal laws. We can also understand the example of and the application of Newton's third law in flying birds. A bird, while flying, pushes the air downward with the help of his wings. Consistent with Newton's third law of motion, the air makes the bird go upward. If the bird is pushing the air in such a way, the air will enable the bird to fly upward in opposite direction. the action of the wings of the birds and the air will be equal but opposite, and this thing will enable the bird to fly higher and higher in the sky. There are million more examples of Newton's third law of motion in our environment. If you observe closely, you can find it anywhere and everywhere. What is sound? Let's discuss and try to understand what is sound. A sound is a form of energy, or we can say that a vibration that travels through a medium like air or water. There can also be solid bodies. These can also be the good sources for the transfer of the sound waves. You know, sound is a form of energy, and a sound is always produced by a vibrating body. If body is vibrating, it will produce sound, but it requires a medium. Medium can be of different types. Solids, liquids, and gases may be the mediums for the transfer of the waves, sound waves. It's something that can be heard. Sound is something that can be heard. The speed of sound is different in different mediums. This is a fact. However, the speed of sound varies from substance to substance. Typically, sound travels more slowly in gases, faster in liquids, and fastest in solids. I have categorically mentioned. For example, while sound travels at 343 meters per second in the air, it travels at 1481 meters per second in water, almost 4.3 times as fast as compared to gases, and at 5120 meters per second in iron, which is basically a metal, a solid, almost 15 times as fast. So resultantly, we can say that sounds basically fastest travel the fastest in solids, faster in liquids, and comparatively slow in gases. What's a wave? A wave is something that transports energy from one place to another through a medium. Example of a pond with still water, with static water, can easily be understood. If you drop a stone in the water, it will resultantly make waves, it will form waves. The water molecules will show some type of oscillatory motion, oscillations, and these oscillations will transfer their energy to the next particles, and they will transfer their energies to the next particles, and similarly the chain of waves is produced in such a way that they are basically moving up and down, but due to this movement they produce energy and they transfer this energy to the nearest particles, and the chain goes on and waves are creating, and this is a continuous process until the water waves get and strike and collide to the edges of the pond. There are three main types of waves, like transverse waves, longitudinal or compressional waves, and surface waves. Transverse waves transfer energy by moving the medium back and forth at right angle to the energy movement. Whereas longitudinal or compressional waves transfer energy by compressing and expanding the medium to move the energy forward in forward direction. The surface waves, on the other hand, transfer energy by displacing the medium in a circular motion. So these three main types of waves are present everywhere around us. Transverse waves cause the medium to move perpendicular to the direction of the wave by making an angle of 90 in the direction of waves. Longitudinal waves cause the medium to move parallel to the direction of the wave. Longitudinal or compressional waves move in such a way, this is called parallel, equal in direction. And in perpendicular motion, which is the motion of the transfer waves, this can be understood as in upward direction, straight, by creating an angle of 90, which can also be termed as right angle. This is angle of 90 basically. What is a sound wave? A sound wave is a simple pressure wave that is caused by the movement of molecules away from the source, and like all waves, we expect it to have a frequency and an amplitude. It also has wavelengths associated with it. There was a time when we had no sources of technology, and the era used to be the era of wars. People used to fight, people used to fight with the help of their horses. And from a specific distance, the warriors used to hear the sound of the hoofs of horses by joining their ear to the ground. This enabled those warriors to hear the sound waves through the vibrations, and they guessed that the horses were moving towards them in order to attack and assail. Similarly, through and with the help of a train track, you can hear the sound of coming train due to the oscillations. Next, as already said, it is a pressure wave. Such pressure causes the surrounding molecules to move back and forth from their equilibrium position. This movement of the molecules determines the frequency and amplitude of sound wave. These properties lend the sound wave its unique pitch and loudness, and the pitch and loudness are quite obvious from their names. An individual with normal hearing can hear sounds in the range of 20 to 20,000 hertz. Hertz is a unit of frequency. How is a sound wave produced? A sound wave is produced in a particular way. Let's consider an example of understanding the production of sound. Let us say someone comes to your door and possesses the doorbell. presses the doorbell, you will hear the sound from inside. Can you guess how the sound traveled? In fact, you know, sound requires a medium for its transfer. And you know, air is present everywhere. Air is the example of gases. So, gas is the medium for the transfer of the waves of the sound wave. It traveled through the air. The sound of the doorbell traveled through the air. Here, the medium of propagation is air. The medium of transfer is air, which is basically a gas. Sound waves and sound needs a medium of propagation. More scientifically, if we understand it, we can see that as soon as the doorbell rang, sound waves were created with which disturbed the immediate layer of air near it. And air, the molecules of air are closely related and closely linked together. Whereas we can say that they are not much closer to each other if we compare the molecules and the particles of the air with the particles of liquids, and with the particles of solids. In solids, particles are quite closer to each other. They are linked. There are no empty spaces among the particles of solids. This is the property of solids, that their molecules are closely linked together. But whereas in liquids, molecules are not more closely linked. They are at certain distances. Whereas in gases, molecules are on higher distances as compared to solids and liquids. This in turn disturbed the layer adjacent, and this way the disturbance got carried forward and ultimately reached the human ear through pinna, which is an external ear of human. And through pinna, sound waves traveled and they collided with the eardrum. Eardrum started vibrations, and these vibrations produced the sound in form of a specific frequency, and your brain enabled and processed those information, and you got understood that someone was knocking at the door through the doorbell. This process took a very short time, as the disturbance traveled very fast and is not visible to the naked eye. You cannot observe the molecules of gases through your eyes. In this way, the sound wave is generated and reached the human ear. Sound energy travels in the form of sound waves. There are mainly two types of waves: transverse waves and longitudinal waves. We have already discussed these waves. Real life examples of sound waves: when we speak, vibrations are produced by the vocal cords and throat. In throat, there is basically larynx, and larynx is understood as a voice box, and this enables human to speak up or to utter the words. And so we are able to produce our sound through the vibration of vocal cords. Vocal cords are bilayer, and these vibrates on their position, and by vibrating the sound is produced. By the vibrations of vocal cords, the sound is produced. Also, when we stuck in the traffic, different sounds waves are generated from the horns of different vehicles, and as the frequencies don't match each other, we hear uneven sound, generally referred to as noise. When the sound is uneven, there is a rush of traffic, and there are all types of vehicles on the road moving. They are producing sounds through their horns, which are irregular. This uneven distribution of sound come to your ear, and you notice some type of irritating sound which can be termed as a noise. So noise is very, disturbing. It causes stress, depression, anxiety, and some type of, depression. Thank you so much for listening.